Oh, okay. So, so yesterday we discussed about structural illustration of Barylic acid, and also we discussed about what are carotenoids and a differences between alpha, beta, gamma carotenoids. And we also discussed about the isolation of carotenoids. And today we will discuss about structural elucidation of beta carotene. Okay, so beta carotene is the major component present in carrot, and of course, it is also a what is called as a terpenoid, more particularly tetraterpenoid, the one we having a 40 carbon atoms. It is found that it is a red crystalline compound. The melting point is found to be 183 degree centigrade. And so unsaturation. So the unsaturation index, how you can find the unsaturation index? You can find by applying C minus hydrogen by 2 plus nitrogen by 2 plus 1. So based on that formula, you will get unsaturation is around 13. So when beta carotene is subjected to catalytic hydrogenation, so it consumes 11 moles of hydrogen. Okay, when beta carotene is treated with hydrogenation, more particularly catalytic hydrogenation, it consumes 11 moles of hydrogen. It indicates that beta carotene is having 11 double bond. So that means uh, this C40H56 is converted into C40H78. Then what is the leftover? Leftover is 4 hydrogen to become a saturated hydrocarbon. So then what will happen? So that 4 hydrogen uh, can be accounted by the bicyclic general formula, that is CnH2n minus 2. Okay. So it is having two bicyclic compounds. That is the reason that's also obese. So then when a beta carotene is exposed to air, so that means beta carotene, when it is exposed to air, it develops the odor of violet. Beta carotene, when it is exposed to air, develops the odor of violet. So this odor of violet is due to the formation of beta ion. Okay, so you know that beta ion is the one of the key intermediate in the synthesis of vitamin A. Okay, so that means carotene on exposed to air, it leads to the formation of beta ion. Similarly, when carotenoid is subjected to oxidation, more particularly in cold condition. Okay, in cold condition, that means carotene is not heated with the KMnO4. So carotene is added to a KMnO4 solution in benzene at cold. Cold means less than room temperature, maybe a 5 degree or 10 degree or 15 degree. Less than room temperature is called cold. Normally around 11 degree or 10 degree. So what will happen? So there will be a oxidation of KMnO4. You know that KMnO4 specifically attacks the double bond. So thereby leads to the compound called beta ion. More particularly, beta ion is formed two equivalent. So what it indicates? Okay, it indicates that these two equivalent may join and form a beta carotene. Okay, that's what we can get it just by looking into this data. So that means beta carotene, when it is treated with cold KMnO4 in benzene, it gives two molecular beta ion. This indicates that two molecular beta ion can join, can form a beta carotene. So with this, I will go to the next slide. Okay, I will go to the next slide. Okay, now it's working. Next, this one, right? So here, the beta ioniine was taken. So that means beta anion, how it is obtained? It is obtained by the uh, cold cheminophore oxidation on beta carotene. So the obtained beta anion was taken and it is subjected to ozonolysis. You know that ozonolysis react with the double bond, form a ozonide, more particularly uh, I think you know that ozonide and then triozonide and then leaving a giving a product. So this ozone reacts with the double bond. Okay, I think you are aware about the application of ozone uh, in oxidation of double bond. So initially react with this double bond, form a triozonide and later on ozonide and then breakage. So giving rise to here COOH. Okay, of course, here also COOH. Keto acid is the byproduct. Then the main product is this is the one is COOH. But this beta anion contains two double bonds. It is also possible to uh, cleavage of this double bond. Initially forming a triozonide and then ozonide and then cleavage. Cleavage means here this carbon gets converted into CO, this carbon gets converted into CO. And one more thing here left over, there is a methyl group here. Okay, so in the product it is there. So in the reactant you write it, there is a methyl group here. So then what will happen? Okay, so there is a methyl group. So that is how a intermediate is formed. So this intermediate undergoes decarbonylation, removal of this carbon monoxide. So giving rise to geranic acid. So what it indicates, geranic acid is obtained on ozonolysis of beta anion. So you know that beta anion is obtained by the oxidation of cold cheminophore on beta carotene. And now at this stage, one more experiment. A carotenoid itself is taken, means beta carotene itself is taken, and that is subjected to ozonolysis. And here also the product formed is geranic acid. So what it indicates? So carotenoids also gives geranic acid. Beta anion is also gives geranic acid. That means uh, carotene should contain a compound called a six-membered ring, and there is a double bond, and there is a dimethyl group, and then methyl group. That component carotenoid should contain. So based on this results, the structure, the partial structure of beta carotene may be like this. So this is one beta anion. Here also you need to write. Okay, what I will do, I will write the methyl group now itself. So here the methyl group is missing. So that means here one methyl group is there. This is no problem. But here there is a methyl group. Here there is no problem. Okay, that's all. I will go back. Right. So now this is the methyl group. Okay, this also a methyl group. Here is the methyl is there. So the two molecule of this is one beta uh, ionone derivative of this is also beta ionone derivative. So the partial structure of beta carotene may be like this. This is one moiety, this is another moiety, and in between you can find a C13 unit. Okay, so this will be the partial structure. So let's go to the further experiments on structural elucidation of beta carotene. So with this, I will go to the next slide. So Here, a beta carotene is treated with malic anhydride. Okay, there is a double bond. There is a double bond, so that is the reason it's malic anhydride. Otherwise, if there is no double bond, means it is a succinic anhydride. So this double bond react with the double bond present in a beta carotene and gives an adduct. So it is found that 5 moles of malic anhydride reacts with the beta carotene and forming an adduct. So what it indicates? It indicates the presence of conjugation. So conjugation means alternative double bond. So that means when a keratin is react with the malic anhydride, more particularly it consumes 5 moles of malic anhydride and gives a adduct. So this indicates that there is a presence of conjugated double bond. So conjugated double bond means alternative double bond is called conjugated double bonds. So with this, I will go to the next slide. So I think you know that geranic acid. Geranic acid is obtained by the ozonolysis of beta carotene. The geranic acid is obtained by the ozonolysis of beta ion also. So this geranic acid was taken and subjected to further KMNO4 oxidation. So what it indicates? It indicates that breakage of here forming an acetic acid. This carbon gets converted into carboxylic acid. That is how the glutaric acid is obtained. This glutaric acid, when it is further treated with KMNO4, a succinic acid, dimethyl succinic acid is obtained. This on further oxidation gives dimethyl malonic acid is obtained. What it indicates? It indicates that there is a 2-methyl group. The gem methyl group is present in a carotenoids. And these are the products, means glutaric acid, succinic acid, malonic acid is obtained on oxidation of geranic acid. Now beta carotene itself, okay, this is a beta carotene. Beta carotene itself is subjected to KMNO4. So here also there is a formation of acetic acid in addition to the dimethyl glutaric acid, dimethyl succinic acid, dimethyl malonic acid. And what is the difference between here and there? So when beta carotene itself is subjected to KMNO4 oxidation, see here it's not a cold KMNO4, it is a warm KMNO4. So it is obtained that there is a more quantity. Here the acetic acid obtained is in large amount. So what it indicates? It indicates that there is a presence of double bond CH2 group. So then only there will be a cleavage here and this part will go out as a acetic acid. Okay. So oxidation of beta carotene on warm with KMNO4 gives a large quantity of acetic acid. It's because of the presence of double bond CH3 groups. Okay. Maybe you can say that vinyl. Okay, you need to mention this structure itself. This double bond CH3 kind of group is indicated by the formation of large amount of acetic acid. So with this, I will go to the next slide. So next slide is one name reaction, Kunrath detection of methyl sites in carotenes. So this will Kunrath is a scientist. He is able to find that determination of methyl sites in carotenes. So what he did, he took the carotene and treated with chromium trioxide in sulfuric acid. You know that chromium trioxide in sulfuric acid is also called as a Jones reagent. Okay, since this Jones reagent is applied on the beta carotene, it's called Kunrath determination of methyl side chain. And what is obtained? The obtained is 5.4 acetic acid molecule, 5.4 mole of acetic acid molecules are liberated. So this indicates that there is a conjugation, 5 conjugations are present in carotenoids. And he's also done one more experiment. So this beta carotene, So it also leads the formation of toluene. It also leads to the formation of xylene. It also leads to the formation of dimethyl naphthalene. So the possibilities of forming a toluene, xylene, naphthalene is explained in the next slide. So I will go to the next one. So these are the possibilities. So 1,4 combination. So this one is called 1,4 combination. This type of combination leads to the toluene, and 1,5 combination. 1, 2, 3, 4, 5. So 1,5 combination leads to the xylene moieties, and 1,6 combination leads to the naphthalene moieties. So this is how the explanation for the formation of toluene, xylene, and naphthalene. So with this, I will go to the next slide. So next, beta carotene is treated. Carotene itself is taken, and it is treated with a dichromate. So you know that potassium dichromate. So what you know that potassium dichromate or KMnO4, both the thing will act as a conversion of a double bond to the dihal. So here, this particular double bond is converted into dihal. Okay, this particular double bond is converted into dihal. So only this changes, not other thing. So that means beta carotene, when it is treated with KMnO4, it converts uh, a double bond in a six-membered ring to the diol. So with this, I will go to the next slide. So here, when the diol is treated with lead tetra acetate. So lead tetraacetate, you know that it will convert a diol to the ketone. So this should be AC. Okay, this is OAC, means lead tetraacetate. So you know that application of lead tetraacetate also. Okay, that converts diol, the vicinal diol to ketone. So then this ketone, diketone, is also called as semi-beta keto, beta carotene. When it is treated with chromium trioxide, so this particular double bond gets converted into ketones. Okay, this is what is called as beta carotene, more particularly tetraketone. Okay, so here means 2 ketone. This is 2 ketone. That means it's a tetra ketone. Okay, and then I will go to the next. So these are the oxidized product. And what is the next target? Next target is synthetically beta carotene was synthesized and compared with the naturally occurring one. So now let's look into the synthesis, how one can synthesize a beta carotene in a laboratory. So that I will take it in a next slide. Okay, this is the one. So you know that it is a beta hyaenone. So what will happen? A beta hyaenone, when it is treated with this group is a bromo. Okay, bromomethyl acetylene. Bromomethyl acetylene in presence of zinc. So this is nothing but a what is called uh, right glycosidic reformesque reaction. So reformesque reaction means what this zinc initially there will be a form a bond with the this carbon. Okay, that means now you know that this carbon is electron deficient one. So when zinc is reacting with this, then this carbon itself is acts as a anion, and this can attack this carbon, and this bond pair attack the same carbon, and Br will go out. Okay, I think you are aware about that. This is similar to the glycosidic ester, the glycosidic ketone formation. Here, this is not ester; it's a ketone. Okay, there will be a three-member epoch. What you called aziridine. Okay, that means there will be a bond formation between this carbon and this carbon, and this oxygen and this carbon. Okay, so now a intermediate is obtained like this, and this intermediate okay, then afterwards what will happen? So when it is treated with the proton source, epoxide is opened and this carbon takes a proton. So that is how a compound is obtained. And this method of synthesis of carotene is given by a scientist called Euler. So here you can make S as a silent. Okay. And that is the reason this method is called Euler method of beta carotene synthesis. Then what will happen? Uh, so this particular one, when it is treated with ethyl magnesium bromide, it's a Grignard reagent. It can abstract this proton, form a magnesium bromide here, and it can also accept a proton here, forms a oxy magnesium bromide here. So that's what the product obtained. And this was taken in 2 equivalent, and this diketone was taken in 1 equivalent. So why? Because one mole, one equivalent of this one is attacking this carbonyl group. Another equivalent of this this intermediate is attacking this carbonyl group. So that is how a intermediate is obtained. So what is the here you can observe that there is a triple bond. Okay, since a reactant contains triple bond, this triple bond is converted into double bond, okay, by the name reaction called Lindlar catalyst, otherwise Lindlar reduction. This Lindlar reduction is only more specifically converts a triple bond into double bond. It does not affect the double bond. That's the speciality about Lindlar catalyst. And Lindlar catalyst is hydrogen in presence of palladium over a barium sulfate. So barium sulfate will act as a poison and poison to this catalyst, and thereby it will stop the reduction at the double bond stage. So obtained compound, you know that hydroxy groups are there, but here there is no conjugation is there. So conjugation can be achieved by converting a hydroxy group into a tosylate. So by converting a hydroxy group into tosylate, that can be made it as a better leaving group. Then afterwards, what will happen? There will be a proton from this carbon coming over here. This will go out. Similarly, a proton removed from here, bonded pair move over, and this will go out. A proton removed from here, bonded pair come over here, this will go out. So that is how a conjugation is achieved, and the conjugated one is nothing but a beta carotene. So this is about the synthesis of beta carotene. Okay, now tell me, do you have any doubt in structural elucidation of beta carotene, including synthesis? Any doubt?
No,
No,
sir.
sir.
Okay, then what I can do, I will go for a question answer discussion. Uh, right. Then I will take up one more slide. So that slide contains a question answer discussion about carotenoids. So that means with this your syllabus, more particularly terpenoids, is completed. Okay. So you just go through the here I am giving a I think I have given questions also. So try to answer it. Okay. If you are finding a difficulty in understanding any concept with respect to the terpenoids or any chapter, what I taught, you can ask me. I will explain it. Otherwise, I will also share a video lecture of respective concept. So then, if you are looking into the question answer, so the what is the first question? What are terpenoids? Okay, and you know that terpenoids are secondary metabolites. Okay, terpenoids are secondary metabolites synthesized by plants, marine organisms, and fungi by head-to-tail joining of isoprene units. All these terpenoids also found to occur in rocks, fossils, and animal kingdom. So that you can explain. And if you want to explain about the general classification, means you can mention that these are classified into monoterpenoids. Monoterpenoids means C10 carbon containing ones are called monoterpenoids. Sesquiterpenoids means C15 carbon containing ones are called sesquiterpenoids. Diterpenoids means 20 carbon containing ones are called diterpenoids. Uh, Triterpenoids means 30 carbon containing ones are called triterpenoids. 40 carbon containing ones are tetracarbenoids, and the remaining ones are polyterpenoids. So that's what you can explain for this question. And if you are looking to identify the isoprene units in the following compounds. So isoprene units means you have to, isoprene means it's a five-membered one. So you can observe that this is one carbon atom, two carbon atom, three carbon atom, four carbon atom, fifth carbon atom. So after this fifth carbon atom, up to this fifth carbon atom is one isoprene unit. And you know that this part is head and this part is tail. So up to this you can mark this is one isoprene units. From this carbon, this is 1, 2, 3, 4, 4, 5. Up to this carbon is one more isoprene unit. So that means you can mark here. And the remaining 1, 2, 3, 4, 5. This is another isoprene units. Totally 3 isoprene units. That is the reason it's called sesquiterpenoids. Okay. This is, you need to mark like this is one, this is another. Okay, in such a way that you have to do it. So you can say here the answer is 3 isoprene units are present, and you have to mark here one and there one. So that's all about this particular question. Then give the steps involved in the commercial synthesis of camphor. Okay, give the steps involved in the commercial synthesis of camphor. So you know that what is camphor? Camphor is a naturally occurring terpenoid, and so more particularly commercial method. Alpha pinene means, you know that what is that alpha pinene? Alpha pinene is a compound obtained from uh, pinene tree itself. So that alpha pinene, when it is treated with HCl, it will give you boronyl chloride. That boronyl chloride on treatment with sodium methoxide, it will give you camphene. That camphene, when it is treated with sodium it is subjected to oxidation by using an oxidizing agent called nitro benzene that converts borneol into camphor. So that's what you Supreme rule means head to tail uh, uh, okay, that is isoprene. Okay, there was a what is called uh, internet issue. I think now we can continue. Look here. I think so. We were discussing about isoprene rule and special isoprene rule. So isoprene rule means naturally occurring terpenoids on eating gives isoprene units. Special isoprene rule means head to tail joining of isoprenes to form a terpenoid is called special isoprene rule. And the structure of limonene is this. So what you can observe here, you have to write the structure, and after writing you have to identify 5 carbon atoms. 1, 2, 3, 4, 5. So up to this carbon atom is one isoprene units, and the next 1, 2, 3, 4, 5 up to this carbon is another isoprene unit. So that means two isoprene units are joined in a head to tail fashion. This is head, this is tail, and this is tail, and this one is head. Okay, that's what you need to remember. So then sketch the synthesis of alpha terphenyl. So if the synthesis of alpha terphenyl is started with the tolic acid. This is called, okay, without this carboxylic acid is called toluene, and with carboxylic acid is a tolic acid. So this tolic acid on reaction with sulfonic acid in presence of base. So sulfonic acid means this particular position gets converted into SO3H group. Thus, that SO3H group is replaced with OH when it is treated with sodium hydroxide. That means there is a formation of OH group at this position, means ortho to the methyl group. Then afterwards, what will happen? So that is treated with bromination. So bromination sorry, that is treated with reduction, more particularly Birch reduction. So Birch reduction means all these double bonds is converted into saturated one. So then that saturated one is treated with what is called HBr. That HBr convert hydroxy group into bromide. And then when it is treated with base, there will be a removal of dehydrohalogenation forming a double bond. And that double bond, when it is treated with esterification, means ethanol in presence of H plus, carboxylic acid is converted into ester. The obtained ester is when it is treated with Grignard reagent called methyl magnesium bromide. So it will give you a alpha terpeneol. Okay. So like that you need to write, and like that you need to practice of writing answer to the questions. Maybe what I will do, I will stop at this stage. Maybe I will continue in the next class with the remaining question and answers on terpenoids. Afterwards, I will start one more chapter in 404. 404 means medicinal chemistry. One unit I will start after the question answer discussions. Okay. So with this, uh, maybe I will stop now. Maybe what?
Excuse me, sir.
Yes.
Sir, please share this PPT, sir.
PPT. You want PPT?
Yes, sir. In that we can read effectively.
Uh-huh. I will share the video itself, lecture video itself.
Okay, sir.
Huh?
Okay,
Maybe
sir.
what we all the classes you want, only particular one. We whatever the one you are asking, those video lectures I will share.
Yes,
You
sir. Yes,
want
sir.
all means I will also share all.
Yes, sir.
You want all, no?
Sir, video lecture no need, sir. Just share PPT, sir. Because in PPT we can read effectively in the sense it will
Both are
color.
both are same, no? Video lecture and PPT both are same only.
Yes, sir.
I will share video lectures.
Yes, sir. Yes, sir.
I will share all the things. Okay.
Yes, yes, sir.
Right. Okay. Okay. Fine. Anyone is having any doubt?
No, sir.
Okay. Right. So maybe you can log out. Maybe tomorrow I will continue the discussion with the question and answer, and afterwards I will take medicinal chemistry, if possible tomorrow or day after tomorrow.
Fine, sir.
Okay.